Okay, so welcome back friends. This video will going to be the third video lecture of enzyme kinetics, where we will going to talk about the effect of Km, that is the Michaelis-Menten constant that we have talked about in the previous video. So if you have not watched the previous video, then I would like to recommend you please go and watch this video, so it will be better for you to understand this video. So here we will going to talk about the effect of Km and the substrate concentration on the initial velocity of an enzymatic reaction. Okay, so there are various conditions that here we will consider, and these conditions are very important for you to understand, because there are various mathematical problems that we will going to do in our upcoming videos based on these conditions. Okay, so before that I want to explain the thing that you have already learned in your class 12 chemical kinetics, that is rate law. Okay, and another important thing that I have learned this in my class 12th from the physics wala Alok Pandey sir. So if you want to know about rate law in very much details, then I would like to recommend you to go and watch the chemical kinetics physics wala. He has already uploaded a detailed video, and one by one in series, and that is in one word: outstanding. Okay, so here I will going to use some points from one of those videos that will going to help us to understand about the orders of the reaction that here we will going to talk about. Okay, so let's get started. First of all, rate law we are tells us about the dependence of concentration of the reaction species on the rate of the reaction. Okay, what is the meaning of this? The meaning is, rate law wants to tell us how the rate of the reaction dependent on the concentration of the reaction species. Okay, that may be concentration of the product or concentration of the reactant. Most of the cases we are taking concentration of the reactant. Okay, so this dependence is very complex, and because it will changes with the change in concentration of the species. Okay, now the question comes, how we can determine those kind of relation. So there is one and only method, that is by the experiment. That means we have to perform experiments. Okay, and on the basis of the result of those experiments we can tell how the rate of the reaction depends on the concentration of the reaction species. Okay, for example, let's say there is a reaction going on 2A plus B, that is the two reactant that ultimately gives us the product. Okay, here we are taking first condition, that is if concentration of A doubled, then the rate of the reaction also doubled. Okay, and we have considered B intact, we have not manipulate B. Okay, so from the first situation we can conclude that rate of the reaction is directly proportional to the concentration of the A. Okay, similarly the concentration of the B, if we double the concentration of the B, the rate of the reaction becomes 4 times, as you can see. Okay, what does it mean? It means that the rate of the reaction will be proportional to the square of the concentration of B. Okay, so that is the idea. Now if we sum up these two, then we will get this thing. Okay, and for removing the proportional term, we have here used a constant, and that is the K. We have already talked about the K in the previous video, right? So this is your K, that is a rate constant. Remember, in the previous video we have also considered K as a constant term. Okay, and this is generally the expression of rate law. Okay, as you can see, it simply depicts the relation between the rate of the reaction and the concentration of the species in reaction. Okay, although this is not too much important for understanding the topic, here I just want to say that these 1 and 2 are generally the order of the reaction. That is my intention to talk about this. Okay, so here 1 is the order of the reaction with respect to the concentration of the A. Similarly here 2 is the order of the reaction with respect to the concentration of the B in the reaction. Okay, so if we now there is another important thing that our sir has mentioned in his video, that is there are two scientists, Goldberg and Weg. They have proposed a principle named law of mass action. There they have told to consider the stoichiometric coefficient of this reactant as their order. Okay, that means according to Goldberg and Weg, the rate of the reaction will be K A to the power 2 V, but it is not always right. Okay, rather I should say that it is in 95% cases it is wrong. Okay, that means for determining the order of the reaction we have to rely on the experiment. That means we have to perform experiments to find out the relation between the rate of the reaction and the concentration of the species in reaction. Okay, there is no other way for that. So now here I have generalized the situation. Okay, so here A is the concentration of the A, concentration of the B. So X here is the order of the reaction with respect to A, right? Similarly Y will be the order of the reaction with respect to B. Here another important thing, the order of the reaction may be negative term, maybe 0, maybe positive, maybe fraction. Meaning, let's say we have performed a experiment where we have obtained that on doubling the concentration of the A, the rate of the reaction halves. Okay, what does it mean? That simply means that the rate of the reaction will be Ka to the power 1 by 2. Okay, similarly it can be -1, it can be 0, it can be positive, it can be fraction. Okay, so now whenever they will ask you the overall order of the reaction, you have to calculate the x plus y. Okay, now the main topic of today's class, that is in the previous video we have derived the formula V0 is equal to Vmax Vmax into concentration of the S divided by Km plus concentration of the S. Here we are first taking the condition where we are taking Km is much greater than concentration of the substrate. Okay, I think you may have done this kind of problems in your physics paper, right? There if we get some type of situation where they are telling that Km is much greater than S, we simply consider that concentration of the S will be negligible. That means Km plus S will be Km. Okay, so that is the thing. So we will consider Km plus S as Km. Okay, so here Vmax and Km both are the constant term, so we can write Vmax by Km as just K. Okay, so now as you can see, if we consider the initial velocity of the reaction as rate of the reaction, then the rate of the reaction is directly proportional with the concentration of the substrate, right? Because here we can also consider substrate as the reactant, right? So here we are getting the first order reaction, right? So when the Km will be much greater than the substrate concentration, the enzyme catalysis reaction will be a first order reaction. Okay, now in mathematical questions they will give you the condition that in that particular enzymatic reaction Km is much greater than substrate concentration, then they will give you the values and they can ask you the value of the initial velocity of the enzymatic reaction. So you have to calculate with the help of this formula. Okay, and MCQ question may also come that at what condition the enzyme catalysis reaction can be an example of first order kinetics. So you have to mark on the situation where Km is much greater than substrate concentration. Understood? Now let's talk about the second condition where we are taking the substrate concentration much greater than Km. Okay, so as a result we will take here Km as a negligible term. Okay, so we will get V0 is equal to Vmax into S by S. So we can cancel S and S. So we will end up with V0 is equal to Vmax. Okay, now here you can see that V0 is nearly independent of the substrate concentration. Okay, that means here we can write that the substrate concentration to the power 0, right? Because we know anything to the power 0 is 1. Okay, so we can easily write. So it is an example of zero order kinetics. Okay, so this is the situation. That means when the substrate concentration will be much greater than Km, the enzyme catalysis reaction will be an example of zero order kinetics. Okay, and now the most important situation. Okay, this case will going to be very important for our next video, where we will going to talk about the Michaelis-Menten equation. Where we will going to talk about the Michaelis-Menten constant, that is the Km. Okay, so here we are taking substrate concentration exactly equal to the Km. Okay, that means here we can write substrate concentration in place of Km. Okay, so we will get V0 is equal to Vmax into S by 2S. Okay, now by cancelling substrate and substrate we will get V0 is equal to half Vmax. Okay, that simply means when the initial velocity will be half of its maximum velocity, the value of Km will be exactly equal to the concentration of S. Please remember the line I have mentioned, because it will going to be a very important line for our next video. Okay, so in this case the initial velocity of the enzymatic reaction is equal to half of its maximum velocity. Okay, so this is the end of this video. So for a quick recap, when we will take Km much greater than S, okay, it will be an example of first order reaction. Okay, and when substrate will be much greater than Km, it will be an example of zero order reaction. Remember it very carefully. And also when Km will be exactly equal to S, this situation will going to be very useful in defining the term Km. Okay, so in the next video we will going to define the term Km. Till then friends, bye, take care.